Hi everybody, I got a couple things here on the screen already, and this is going to be Chapter 6, Homework Number 2, Homework Solutions, Chapter 6, Homework Number 2. This goes over Hess's Law. So I'm recording this video before we've really had class on Hess's Law, so I'll be assuming that we know most of it, so if you're watching this ahead of time it may be confusing, but bear with me. So Hess's Law, look over here, we have two reactions. I'm not going to say them out, that'd just be a waste, but we have them when they have two reactions, and they give us the delta H for both of them. Now right here it says the overall reaction. Oops. The overall reaction, N2O4 equals 2NO2. So these both these equations up on top here, number 1 and 2, have to be set up the same way as that. So now if we look carefully, we'll notice that on the first reaction we have 2NO2 on the products, but on the final one 2NO2 is in the 2NO2 in the first one is in the reactants, and in the final it's in the products. We have to base everything off the one in the final, so we have to flip that top reaction. So it's going to look something like this now. 2NO plus O2 equals 2NO2. We have to bring the delta H with us, but we now switch this to negative 109 kilojoules. Now the second one, we notice that N2O4 is in the reactants, so that is nothing needs to be done to that. Delta H equals 172 kilojoules per mole. Alright, so now we notice that we have negative up here and positive down there. Now to reimburse this, we see this is a negative value right here. This value is negative because we had to flip it, because 2NO2 in the overall final reaction is in the products. In reaction 1 it's in the reactant, so that needs to be flipped. So now we're just going to do a little crisscross. We'll notice that 2NO will cancel with 2NO, and we'll also notice that O2 will cancel with O2. So now once we figure that out, we bring everything down. We get N2O4 equals 2NO2. Now that looks very similar. That matches exactly what is up here, which is what we want. However, now we have to find the enthalpy for reaction 1. So, the enthalpy, we have to find the final enthalpy. So what would the final enthalpy be? Well, let's see. All we have to do is you add up these two values, plus 172, and you get a value of delta H equals 63. That value is the final enthalpy that you're calculating for. We're gonna do some more that are a little more complicated on the next slide. Alright guys, so before we even get started, let's figure out what we're dealing with. We know that right here, CaOS plus CO2 gas equals COCO3 is the final. So these two reactions right here, these chemical formulas, these need to match up to this final one up here. So that's what we're dealing with. So let's look at this first of all. What do we know? We know that COS solid is in the reactant, CO2 is in the reactant, COCO3 is a product. Well, let's look at the first one, CaCO2. CO2 matches with that. Plus O2, we don't know anything about that yet. We notice that CaCO3 is also in the product, so that one is fine. That doesn't need to be flipped at all. However, let's look at the next one. 2CaO solid, 2Ca solid, we don't know anything yet. O2, we don't know anything about that yet. Then it says the product has a CaOS solid in it. But we know that that in the final is a reactant, so this one right here needs to be flipped. So why don't we write this down? We have Ca solid plus CO2 gas plus 1/2 O2 equals CaCO3 solid with a delta H of minus 812.8. That doesn't get changed, correct? correct because it doesn't get changed because we didn't flip it at all. We didn't multiply it at all. We didn't flip it at all, so that just stays the same. The next one, we notice that the 2CA, the 2C AO right there, that belongs in the reactant, so that gets flipped. So we get 2CaO solid, 2CaS plus O2 gas. Now it is very, very important to remember to write these things, like the states of matter in this correctly. Now, it's according to up here, it says 1269, negative 1269, but since we flipped it, we also flipped the sign on that, so we should get something like this, 1269.8. I'm not putting the units in here just for space right now, but they should be there. Alright, now here's a trick on how to solve for these ones. In dealing whether to multiply or divide, or what number to multiply and divide each each formula by, or each equation by, you just look up here in the final. CaO plus CO2 equals CaCO3 solid. Now you notice these are all not just pure substances, they're compounds. There's something more complex rather than a pure element like O2 or Ca, where that's just one singular element. These are compounds, right? So how you figure it out is you look at the compounds in the final reaction. In this case, they're all compounds, and you look at the coefficients in front of them. This has 1, this has 1, this has 1. And then you look into the equations down here, and you look at the compounds that are similar to the final up there. CO2, that has 1, that has 1. CCO3, that has 1, that has 1. So nothing needs to be done there. Then we look down at the second one. Ca doesn't know, we don't know anything. O2 don't know anything. 2CaO, that has a 2 and has a 1 up here. So we need to get rid of that 2. So what you do is you divide by 2. So that makes this into a 1. Whoops, sorry. This becomes a 1 now. 1. This becomes a 1. This becomes a 1/2. Alright, now it's time to cross out. So the final has CaOS plus CO2 gas equals CaCO3. So that's Ca up here. Something must happen to it, and in fact it does. This gets cancelled out with this. Then we have CO2. That belongs with this. Let's ignore that for now. Then we have 1/2 O2. That's not in the final at all. So that must get cancelled out. And look, it does right there. So it looks like we have everything cancelled out, so now we just bring everything down. Right here, this comes down, so we have CaO solid plus this comes down, CO2 gas equals, and this comes down, CaCO3 solid. Does this look identical to up there? It does. This looks like the final, so it means we have calculated and solved it. Now finally, we just add up everything. We have to add up this. Oh, I made a mistake. I hope some of you guys caught that. I forgot to divide the value of the delta H by 2. So now we add up everything. We add the delta H for the first one minus 812 plus the delta H of 1269 divided by 2. And I got a value of negative 177.9. Alright, so we have another one that's very similar to the one we just did before. So we're going to follow the same steps. I'm just going to be a little bit more quicker this time since you guys should be better at this now. We have CH4 gas plus 4Cl2 gas equals CCl4 plus 4HCl. Alright, so now we're just going to figure out what we're flipping, what we're not flipping. Here we have CS plus 2H2 equals CH4. We notice that CH4 is in the reactants, but it's in the products here. So that's going to be flipped. So I'm just going to write that here for now. It's going to be flipped. Then the next one we have C plus 2Cl2 equals CCl4. That's the same as there. So same. The next one, H2 plus Cl2 equals 2HCl. That stays the same because we notice that's the same as there. So why don't we just go ahead and write this down now. We're going to have C solid plus 2H2 gas equals CH4 gas with the delta H of negative 70. Oh, I apologize, guys. You know I did that wrong. What did I do wrong? Well, if you didn't notice it, I should have flipped it. I didn't flip it. I wrote flip there, but I didn't write it out. So we get CH4 equals C solid plus 2H2 gas, and this value equals 74.6. This next one stays the same. C plus 2Cl2 CCl4. I'm being quick and I'm not writing the states of matter, but as I said before, you should always write the states of matter because there's some more complicated ones where the states of matter are required. Now it comes to, are we done? No, we have to multiply some things, divide some things, or what do we even do? Or is everything the same? Well, let's look at that rule I said before. We look up here at only the complex compounds. We have CH4, we'll consider that complex. 4Cl2, that's just an element. Well, two of the same elements. CCl4, compound. 4HCl, compound. So you know this has 1, this has 1, this has 4. So let's look at the formulas. C2CH4 has 1 in the final and 1 right there. So that doesn't need anything, we think. And we look at the next one, then we have 2Cl2, then CCl4. CCl4 has 1, this has 1. You notice this has 4, this has 2. But like I said, we ignore the elements, we just look at the compounds. I mean, like the pure elements. One which is, that's Cl and a Cl. So now we look at the next one, H2, Cl2, 2HCl, 4HCl. We're going to have to multiply this by 2. Now multiplying this by 2, everything gets multiplied. This becomes 2, this becomes 2, this becomes 4, and this becomes whatever that value is times 2. So we'll figure that out. If you guys want to type that in, do whatever you like. So now it comes to swiping away. The final has CH4 in the product, so that's going to hopefully stay if we did everything correctly. But there's no C in there, so this C gets crossed out with this C, because this got flipped, so you can kind of say that's a negative, that's a minus, if that makes you feel better. Then we notice that we don't need, we need Cl2 to add, so we have 2Cl2 here, 2Cl2 here. That equals 4Cl2, correct? So let's write some down. We have CH4 plus 4Cl2. Now why doesn't this get canceled out and why they added up? Because like I said, you can think of that as kind of negative and these are positives because that got flipped. The bottom two didn't. Alright, so now we have that and we have an equal sign and we should get CCl4 in the bottom and HCl. But wait, we have some extra hydrogens here. But these cancel out here. These cancel out here. So then we get 2. Oops, I apologize. I screwed up there. So we should be getting CCl4 here. And as you see, it's right there. CCl4 plus 4HCl. And look at that. That 4 came there after we multiplied by 2. So we get 4HCl. Are we done? No. Now we have to add up all the enthalpies, the delta H's. So we get 74.6 plus negative 95.7 plus negative 184.6 times 2. And I got a value of negative 390.3. Now, these problems, guys, I recommend you do these all up by yourself and write every single step out like I did here because it's a lot easier to see your own handwriting. It gets a little messy when you have someone on me on a tablet just writing this out. So try these problems out, do them yourself, and if you have any questions, just ask me during class this week or email me. Well, I'll have another video posted later this week of the ones after this in the homework. They're a little bit different, but they're actually a little bit easier. So have a good one.